Okay, this is a response, just a quick response to questions that I've had from various people all over the world, in fact, regarding pulse width modulation, without getting too technical about it. They just want to understand the basic functions of how these things work, how to control them, and a main question is why these pulse width modulators that they bought have failed after probably a couple of weeks use, driving the Hho cell, and obviously they've not been satisfied. They've had to either throw them away because they don't understand, and it's a waste of money, obviously. Now these PWMs that you buy basically off eBay, they're from China, and they're not bad little units, but they're originally designed for controlling low ampage motors and things, speed controllers. They're not really suitable for prolonged high ampage use, and I've had a couple, and they've all failed, and I've had to modify them, and okay, I mean, with modifications you can make them work perfect. I don't buy them anymore. I prefer to make my own. This little circuit I've got here, as you can see, there's no MOSFETs connected to it because this is the driver, and I use this basically for testing MOSFETs and testing circuits to make sure everything's okay. I use the LM324 IC chip. I use all 4 transistors inside. I can't see the point of installing extra transistors and not using the 4 that's already there. This basic circuit works perfect. Like I say, all the 4 circuits are used in the IC, and of course it's controlled remotely by the 10K potentiometer, which is a usual procedure. You can put that anywhere in your car dashboard. Protect it with fuse, 3-5 amp fuse, diodes of course to protect the circuits, and normally you'll have no problem. So basically this is what I do. I make my own. I do not buy Chinese PWMs because I know from past experience that they won't last. They'll let me down. So okay, now then, the next question, obviously without going into no technical details, you don't want them, you've not asked for them, so this is just basic. This, as I say, is a plug-in just to test MOSFETs, see what the outcome is of any projects. So that's fine. This is what to do. Now, as regards the PWMs failing, this is the reason, and this is the prime reason. The heat sinks that they fit. Basically, this is the most common one. It's completely unsuitable for high ampage. It's nowhere near big enough. Without any extra cooling, even with a fan, this thing won't survive. There's nothing wrong with the MOSFETs. They're okay. They're high-powered MOSFETs, but they need cooling, and they need cooling very bad. So these are no good. A prime example, which I'd like to show, it's not a PWM. It's a little amplifier unit, which is fine, but this unit, as you can see, is fitted with something like a 6mm aluminium heatsink with extra heatsinks on the back, and this thing still gets hot. That hot, you cannot touch it. So obviously that is a heatsink problem. So back to the PWMs again. What I do, if I can't buy, or I can't afford to buy, whichever, because heatsinks are not cheap, you can make your own, get some decent aluminium. You can make your own design. The bigger the better. Overspec it and make it really, really substantial. This is an idea, and it works, it's good. Couple of MOSFETs there, ready to be mounted on this particular heatsink, which is a computer heatsink, which is very, very substantial. It's about 50mm square, or thereabouts, 50-60mm, round about. So I'll just chop the MOSFETs off it, and as you can see, And this is a substantial heatsink. It's heavy, it soaks the meat up, and it's got a built-in fan, built-in cooling fan there, which obviously is going to do the trick. Now, I've not actually tried this one yet, but I know for a fact that this kind of heatsink, with the extra cooling as well, will be sufficient without beefing it up. But if it did need anything added to it, I'd connect this to another heatsink. The more the merrier. Beef it up, make it as big. Make it as big as you like. If you want to go to 3 inches or 4 inches diameter with the fan, make a big heatsink. Because if you do, then I can assure you your MOSFETs will last, and they'll last a lot longer. So that's the heatsink problem. Bear this in mind all the time, of course. The MOSFETs, when they're bolted to an heatsink, the drain obviously is completely the drain is in actual fact in constant contact with the heatsink. So in other words, the heatsink is live, not with the source, but with the actual load or drain. So the drain terminal, which is the middle pin, is obviously connected to the outer case of the MOSFET. So when that's bolted to the heatsink obviously is the direct contact to the middle pin. So you've got to bear this in mind if you ever do mount this complete assembly that you've made in a metal container, a metal enclosure, which is okay. Then you've always got to be sure that if you connect the heatsink to the outer enclosure, which a lot of people do use the outer enclosure for an heatsink, which is fine, you can do that, you must also make sure that this metal enclosure is always insulated from the chassis, from the actual source, which is normally the chassis ground. So that's fine, you can use that, but make sure this is insulated at all time from the vehicle chassis, because otherwise you'll short the MOSFET out, simple as that. So basically what we're looking at now is a simple explanation. Is your MOSFETs will fail, even the high-powered ones, if you do not provide them with adequate heatsink and cooling. The bigger the better. They do get warm, but they get quite hot actually. Never run a MOSFET without an heatsink. You'll blow it up, you'll fry it immediately. So basically that's the question. If your PWM from China is failing after a couple of weeks use at something like 20 amps, which it should do if it's a 30 amp, it's down to this little thing here, which is no good. Replace it, beef it up, add things to it, build it, strengthen it, and then you'll have no problem. I've been running homemade PWMs for months without any problems at all. This little unit will survive with adequate cooling, and it lasts and it's good. Simple and effective. So there's your basics. Heatsinks, and if you have to buy from China, beef your heatsink up. If you're capable of making your own unit, go for this basic circuit. Use this instead of adding all the extra all the extra components that you don't need. You just don't need them, not to control basic ampage. And this is all you want to do, is turn your ampage up or down to control your HHO cell. So there you go. Any more questions about this circuit, let me know, and I'll be happy to post a diagram of this, because it's originally designed as a motor speed, but with adequate heatsinks and MOSFETs, this driver unit will drive. Well, it's a gate, obviously, the gate that's driven by the. You know, it's quite simple. I think everybody understands how it works. It's quickly adjustable. It sends a varied voltage to the gate to adjust the ampage. So there you go. So there's no problem there. Any questions, just email me, post me on YouTube or whatever, and I'll be happy to help if I can. So there you go. There's your problem. Heatsinks. Bye for now. Thank you. for watching.